everyone, myself Prayag Patel, working as assistant professor in IT ICT department of LJ Institute of Engineering and Technology. Now in today's video lecture, I will discuss about the trees and sorting. So we already know the sorting algorithms, but what is the use of the tree in sorting algorithm? It is a main fundamental. Now here, for example, in a bubble sort, the worst case time complexity equal to n square. Now here we discuss the merge sort algorithm, which can be solved using the divide and conquer technique. Now here in the merge sort, the worst case time complexity equal to n log n base 2. This will be accomplished in the following manner. So here we can say that the first we shall measure the number of comparisons needed when n is a power of 2. Then we shall cover the case of general n by using the optional material on divide and conquer algorithm. So basically merge sort use the divide and conquer technique. That means we divide the problem into sub problems and we can solve this algorithm. So our complexity of the merge sort is n log n in place of n square in bubble sort. So basically in merge sort we divide the problem, and this division, this process can be represented using the tree. That's why we can say that the trees and sorting concept is most important. Now after that, given a list of n items to sort into ascending order, the merge sort recursively split the given list and all the subsequent sub list in half or as close as possible to the half until each sub list contain a single element. That means we divide the problem into sub problems until we get the individual element as a single element. So for the each and every element we find the single element, individual element, unique element. Then we stop the dividing process. Then the procedure merge this sub list in ascending order until the original n item have been so sorted. So after dividing we combine this list, means merge this list, and merging process is considered as a sorted list, as a merged list. The splitting and merging process can best be described by a pair of balanced complete binary tree. So complete binary tree or complete balanced binary tree is used for merge sort algorithm. So basically tree used for representing this division operation, merging operation like this. So here splitting or combining process can be represented using the balanced complete binary tree. Now here understand the what is the merge sort example. So consider this example for the merge sort. Value is like 724, 521, 298, 529, 31, 189 and 451. Now arrange this element into the ascending order using merge sort. So basically this all the list is considered initially as an unsorted list. Now we have to arrange this list into ascending order. That means arrange or sort this list. Now first step, split the selected array. That means divide this array into two parts. So in this array we have a total 8 elements. So divide this array into two parts. So in both the part we have a n by 2 elements. That means first left sub part consider as a 1, 2, 3, 4 and next part consider as a 5, 6, 7, 8. So in both the list we have a total 4 element is available. Now after that we have to divide this list into sub list until we will get the single element. So select the left sub array and split this sub array. So left sub array is a 1, 2, 3, 4. Divide this list into two parts. So left part containing the 2 element 1, 2 and right part containing the 2 element 3, 4. Now for the 1, 2 element also we have to divide this list into two parts because here 2 element is available. So we divide this list into two parts. First as a 724, second one is a 521. Now after division, when we get the individual element, then we start the process of merging. So basically here we merge these two elements, first and second location. Then we will get the one sorted list, and this sorted list contains the 1 and 2 elements. So here first we put the smallest element, then we put the largest element. So 521, then 724. So this 2 element is a sorted element. Now same way we have to perform the operation for next 2 element 3 and 4. So 2 and 98 also we divide this list into two parts because we have a more than one element is available in a list. So 2 as a left part, 98 as a right part. Now after that Here 3 and 4 both are the individual element, both are the single element. So combine these two elements. So here combine, after combine we will get the 2 and 98. Now after that combine these two sublists, 521, 724 and 298. Now after combining we will get the resultant list as a 2, then 98, then 521, then 724. Now this is a process for the left sublist. Same process will be follow for the right sublist also. So for the right sublist, select the right sublist, then split this list into two parts. So in this two part, we can say that the 5, 6 is a left part, 7, 8 as a right part. Now in 5, 6, we have to divide this list into two parts, 5 as a left and 6 as a right. After that, we have to combine these two elements. So after combining, we will get the sorted list, because at the merging step, we have to arrange this list into ascending order. So first 31, then 529. After that, we have to divide the 7 and 8 into two parts. So 7 as a left and 8 as a right part. Now after that, we have to combine these two elements, because all the elements are individual elements. So here we can say that the combination is 189, then 451. Now after that, we have to combine these two sublists, 31529 and 189 with 5451. Now after combining, resultant list is like 31, 189, 451 and 529. Now after that, here left sublist is also arranged, right sublist is also arranged. Now after that, combine these two sublists and resultant list is like this. Now in the resultant list, we have to compare the first two elements of the first both the list, because first list is already sorted, second list is also already sorted. So that's why we have to compare the 2 with the 31. Now here which one is the smallest? 2 is smallest. So we put the 2 in resultant list. Now after that, we compare the next element of the first list as a 98. So 98 compare with the 31, because already we can say that the 2 is put in the resultant list. So compare 31 with the 98 and put the 31, then 98, then 189, then 451, 521, 529 and 724. So this is a sorted list. Now basically in this algorithm or in this example, we perform the two steps. First step is a split or divide step, and second step is a combine step. So first here we perform the first three steps as a splitting step. Then after we have to perform the operation for the merging. Now this tree or this example can be represented as a complete binary tree. So we can say that the complete binary tree can be applicable for the merge sort solving, or for find the solution for the merge sort. We can use the complete binary tree. So this is an application of the complete binary tree. Now after that, in merge sort we perform the so many operations. So for the merge sort, one theorem is here, like let L1 and L2 be two sorted lists of ascending numbers, where Li contain Ni elements for I equal to 1 and 2. That means L1 contains N1 element, L2 contains N2 element. Then L1 and L2 can be merged into one ascending list L using at most N1 plus N2 minus 1 comparisons. That means both the list 1 and list 2 are already sorted. We have to only merge these two lists. Then merging step requires the how many number of comparison? N1 plus N2 minus 1. That means N1 means number of element in a first list, N2 means number of element in a second list. To merge L1 L2 into a list L, we perform the following algorithm. So for merging, this algorithm is applicable. In algorithm, step number 1 is set L equal to the empty list file. So initially list L equal to empty set. Now step 2, compare the first element in L1 L2, remove the smallest of the two from the list in it is and place it in the list of the end of the L. So we can say that the compare the first element of the L1 with the first element of the L2 and put the smallest value in our list L. Okay, so this is a step 2. Now step 3. For the present list L1, L2, there are two considerations. First one is a. If either of the L1, L2 is empty, then the other list is concatenated with the end of the list L. This completes the merging process. So for example, one list L1 is empty and L2 having some element, then directly we have to put all the element of L2 in our resultant list, because we can say that the first list is empty. So directly we put this element. So no comparison required for remaining elements. And second part B, if no, then return to step 2. That means list 1 or list 2 is not empty. Then perform the step number 2 recursively until we get the one list as an empty list. Then we stop the process after completion of the step 3. So this is a simple algorithm or theorem for the merge sort. Now here for this example, we can say that each comparison of the number from L1 with one from L2 results in place of an element at the end of the list. So there cannot be more than n1 plus n2 comparisons, because we have a n1 element in first list, n2 element in second list. So maximum comparison is n1 plus n2, not more than that. When one of the list L1 or L2 becomes empty, no further comparison are needed. So the maximum number of comparison needed is considered as a n1 plus n2 minus 1, because when first list is empty, then no comparison required of the second list element with the first list element. So 1 minus comparison is required as a maximum number of comparison equal to n1 plus n2 minus 1. So for example, in first list we have a 3 element 298, 521. In second list we have a 2 element 31, 189. Then how many number of comparison required for merging these two lists? First comparison is 2 compare with 31. Second comparison is 98 compare with 31. Third comparison is 98 compare with 189. Next comparison is 189 compare with the 521. Then after only one element is remaining 521. So no need to compare. So only 4 comparison is required. That means according to theorem n1 plus n2 minus 1. So n1 means 3 element in first list, n2 means 2 element in second list, and minus 1. So total equal to 4. So we can say that for this example we can prove that n1 plus n2 minus 1 comparison is required for merging two lists. Now after that, algorithm for the merge sort. So step 1 for the merge sort algorithm is, if n equal to 1, then list is already sorted and the process terminates. For example, only one element is available, then no need to compare this element, because one element is considered as an already sorted element. Then after, if n greater than 1, then go to step 2. So for n equal to 2, 3, 4, we have to perform the step number 2. Now in step number 2, divide the array and sort the sub-array. Perform the following operation. First operation is assign m the value n by 2. So here divide the value of n by 2 and we can consider the middle point as a m. Now after that, second step is assign to list 1 the sub-array, list 1, list 2, list 3 up to list n. So first element to mth element consider as a sublist 1. Now after that, second sublist as a assign to list 2 the sub-array, list m plus 1, list m plus 2 up to the list n. So middle point plus 1 to last point consider as a second subarray. Now after that, step number 4 as a apply the merge sort to list 1 and list 2. So list 1 size is m and list 2 size is n minus m. And step number 3 is merge list 1 with the list 2. We already understand the algorithm for the merge. So according to merge algorithm, here we perform the operation for merging list 1 with the list 2. So this is a simple algorithm for the merge sort. Now in merge sort, what is the complexity? We already told you complexity is n log n base 2. But how we can find this complexity? For that we consider the recurrence relation. So your recurrence relation is like this: t of n equal to t of n by 2 plus t of n by 2 plus c into n for n greater than 1. And for n equal to 1, we compare the only 0 element, no need to compare any element, so t of 1 equal to 0. Now in this equation, why we write the first t of n by 2? First t of n by 2 means time required by the left sublist to get sorted. Now second t of n by 2 for the time required by the right sublist to get sorted. And here c into n is used for the time taken for combining the two sublists. So this is a recurrence formula for the merge sort. Now we already know the how we can solve the recurrence relation. So here each recursive call focus on n by 2 element of the list. After two recursive call, one call is made to combine these two lists. So for solving the recurrence relation, we have a master's method, and using the master's method, we can solve this recurrence relation. So for the master's method, common formula for the master's method is T of n equal to ATn by B plus f of n. Now, see here, what is the formula for that? T of n belongs to theta n raised to d if a less than b raised to d. T of n equal to theta n raised to d log n if a equal to b, and T of n equal to theta n raised to log a base b if a greater than b raised to d. Now here, what is the value of a, b and d? So for that, here T of n equal to 2Tn by 2 plus c into n. Here, what is the a? A equal to 2, b equal to also 2, and d equal to 1, because power of the n equal to 1, n raised to 1 in a functional part. So d equal to 1. So using this formula, we can compare the a with the b raised to d. So here a equal to 2 and b raised to d equal to 2 raised to 1. So 2 equal to 2 is satisfied. That means case 2 is applicable. So equation for the case 2 is T of n equal to theta n raised to d log n. So now put the value of d here. So d equal to 1. So answer is theta n raised to 1 log n. That means the complexity of this merge sort algorithm is n log n. So in this lecture, we discuss about the what is the trees and sorting. That means how we can use the trees for sorting of merge sort or divide and conquer technique. So in divide and conquer technique, we can use the tree. Thank you for watching this video.